Alright, so today's second question is sorted array, search and rotated sorted array. So if we drop the term rotated, searching a sorted array, it's using binary search in log n time. And the difference is in this term rotated. So the array is sorted in ascending order, so it's increasing in the beginning, and it's rotated at some point. So we take 0, 1, 2 and shuffle that towards the end. It becomes increasing and drop and then increasing again. So we look for running binary search on this rotated sorted array in some kind of a modified version, and to maintain this time complexity, but still be able to correctly find whether the value is in there or not. If it's in there, we return the index. Otherwise, we return -1. So when you think about binary search on a totally sorted array, we take a number, and just by the relationship between that number and the search value, we can know whether we continue search in the second half or in the first half. But for a rotated sorted array, since it's if you take a number here, it will become you basically divide the array into two halves. Let's say that we take the middle number 7. The first half is strictly sorted. So based on the two numbers on the boundary, we know every number in between is going to be in between these two numbers. So if the target is in here, it's in the sorted part, then we just keep searching for that. Otherwise, we should search for the rotated sorted part, because the 7, 0, 1, 2, it can potentially go up to even higher than 7, and it could potentially go lower than 0. So the two boundary values here, 7 and 2, doesn't tell you to which extent you can go up and go down. So if the target value is not in the sorted part, it's only possible that in the rotated sorted other half, you might be able to locate it. And then there is this another situation is that you have to determine which side is sorted and which half is rotated sorted. So the condition from the original binary search, which is either go left or right, based on just one comparison of the selected value is the target, will become based on two things: which half is sorted, and whether the value is in the sorted or not. So it become a table of 4 different situations. So that's all we need to modify to get this thing working. So let's code this. So we have the left and the high, low and high, meaning the two boundaries for the search. And the middle is the randomly selected. It's going to be the middle point we use to try to reduce the size of the problem into halves. So the termination is that these two pointers meet each other. That will indicate that we couldn't locate such a value. So if we couldn't locate that value, we would just return -1. And we calculated the middle point by taking the average of these two, low and high. And if the randomly if this middle point is exactly the target, we should return that. Otherwise, we would just do the comparison to figure out which part is sorted, which part is a rotated sort, and after that, we figure out whether we should look into the sorted part or we should look into the rotated sorted part again. So the condition is compare this with the left number. If this one is larger than the left-hand side one, it's indicating that this portion, the left-hand side, it's sorted. Just quickly note here, left is sorted. With left being sorted, the right-hand side must be rotated sorted. Yeah. Yes. And then we just try to see whether the target is in the sorted part or the other way around. To determine that, because the sorted part, the number is in range of the left and right, so we look into the left hand side. Otherwise, we look into the right. So the condition here is similar. It's just the sorted part is now in the right half. So this should be the code. The only complication between this and the vanilla binary search is that which part we go depends on two things. That's which side is sorted, and then after we know that, we should determine whether we are in the sorted part or not, whether the target is in the sorted part or not. So the simple if-else becomes a table of 4 different situations. Let me quickly check if we have problems. This initialization to be left and rightmost, and for each iteration we calculate the middle point. We compare that value with the target, and if it's not the one we're looking for, we try to determine which side we go to reduce the problem size. And if left hand side is sorted and it so happen the target value to be in that sorted value, we just search for this part. Otherwise, we look at the other half, and it's the same story here. It looks right to me, so let's submit this. Okay, it's working. So yeah, that's a question for today.